Hello students, this is Mr. Sims and I have the second part, examples 2 and 3 from day 11, ratio of fractions and their unit rates. So I'm still on the page that has the lesson objective, so just reviewing the lesson objective, we are finding and comparing unit rates that have fractions and or decimals. Actually, I should probably decimals in there as well. Notice I have changed the color of my pen just to kind of, change it up just a little bit. So we're going to move on to the next page, and in example number 2 states, is Meredith correct? So looking for the gist, which is the what. What is the unit rate expressed in miles per hour? Okay, very, very good. So now, as I read, a turtle walks 7/8 of a mile in 50 minutes. All right, so we want to know if Meredith is correct. So to find the turtle's unit rate, Meredith wrote the following complex fraction. Okay, so that complex fraction just is when you got a fraction inside of a fraction. So like having a fraction on the top and a fraction on the bottom. Okay, it's just another way of writing 7/8 divided by 5/6. But as we have mentioned, or as I have mentioned to you in the past, you won't see this symbol very often moving forward. So we really want to get you used to seeing division represented with the fraction bar, and even if it involves dividing fractions. So that's really what we're kind of shift our focus towards. All right, so to find the turtle's unit rate, Meredith wrote the following complex fraction. Explain how the fraction 5/6 was obtained. So what's going to happen is you're going to take a second, the video will pause, and I want you to think about that for a minute. Where does 5/6 come from? All right, now that you've done that, 5/6. All right, so here's the thing, and this is going to happen a lot in problems that we're going to face. You're given a time unit in minutes, where they want it in hours. So where 5/6 comes from is you have 50 minutes out of the 60 minutes that are in an hour. And then 5/6 is just the reduced version of this. If I divide both these fractions by 10, or both of these numbers by 10, I get the number 5/6. So that's where 5/6 comes from. Okay? So now what we can do is we can go ahead and we can determine that unit rate by using 7/8 divided by 5/6, using our keep, change, flip model. 7/8 times 6/5. Okay? And what we can do beforehand is like we did before. If we can, let's see if we can reduce or simplify beforehand. So 8 and 6, 2 goes into 6 3 times, 2 goes into 8 4 times. So then we have 7 times 3 across the top, which is 21. And we have 4 times 5, which is 20. So determine the unit rate expressed in miles per hour. We have 21/20. But if we think about that, if we rewrite it as a mixed number, okay, hopefully you remember how to do this. There is a button on the calculator that will do this for you. Once I find out we're using calculators for the state test, then I'll show you more of those. So one here, you got 1 left over. So this is really 1 1/20 miles per hour. All right, so just a little more over a mile an hour. Okay, now we have example number 3. All right, read the gist. Is there enough flour for each of his friends to get a cupcake? So have that in mind. Is there enough flour? So for Anthony's birthday, his mother's making cupcakes for his 12 friends at his daycare. The recipe calls for 3 1/3 cup of flour. This recipe will make 2 1/2 dozen cupcakes. Problem is, Anthony's mother only has 1 cup of flour. Is there enough flour for each of his friends to get a cupcake? All right. So essentially what we would be looking for is, and it doesn't tell us how to find the unit rate, but typically we want to find out, we got 1 cup of flour. That means that we want 1 cup of flour. We want flour to be on the bottom, and we want to figure out how many dozen cookies. So we're looking at dozen cookies per cup of flour. So we'd be finding the unit rate of 2 1/2 dozen divided by 3 1/3 cups of flour. All right, to determine if Anthony's mom will have enough cookies for his friends at his daycare. All right. So now what we can do is we can rewrite this as 2 1/2 divided by 3 1/3. Okay. This is probably the only time you'll ever really use this symbol from here on out is when we're doing fractions and mixed numbers. So we are going to make these both improper fractions. I guess the phrase is getting mad. But 2 times 2, which is 4, plus 1 is 5 over 2. 3 times 3 is 9, plus 1 is 10 over 3. Like so. Right. And we can, I know some of you might already be working ahead on this, but keep change flip. 5 over 2 times 3 over 10. Okay. And we can do a little bit of cross canceling. So 5 and 10, 5 goes into 5 once, 5 goes into 10 twice. So we end up with 3 over 4. And that's 3 over 4 dozen. So we get 3/4 of a dozen cookies. Right? So now where one more piece is in order to determine if there is enough flour for each of his friends to get a cupcake, well, if you have 12 friends, well, 12 friends equals 1 whole dozen. And if we only have 3/4 of a dozen, the answer to this question is no. He will not have enough. Right? So this is a way that we can use math, use work to show or justify that Anthony will not have enough cookies for his friends. All right, so this is the conclusion. So the rest of the time in class will be spent on working through exercises on the next page, 58, and the independent practice starting on page 59. So this is Mr. Sims signing off.